A 3-meter CNC press brake is a six-figure purchase, and tonnage is the single biggest thing driving that price. Most buyers get the number wrong. They overbuy by 100 tons and waste the budget, or underbuy and start damaging the machine inside a year. Here's how to get it right. It comes down to one formula. Force equals 1.42 times tensile strength times thickness squared times bend length divided by die opening. Every variable matters, but one dominates. Thickness is squared. That's the trap. 3 mil mild steel over 1 meter in a 24 mil die needs about 24 tons. 6 mil in that same die needs close to 100. 4 times the force for double the thickness. The die opening is the other number people miss. Standard rule, V equals 8 times material thickness. 3 mil goes in a 24 mil die. Go narrower in tonnage rockets. A die at 4 times thickness doubles the force. Tight enough and you crack the punch. The die opening also sets the inside bend radius. In air bending, the radius is roughly the die opening divided by 6. Wider die gives a bigger radius and less tonnage. Narrower die gives a tighter bend and more force. Every bend is a trade-off. Material changes everything. Mild steel at 450 megapascals is the baseline. Stainless, 304, runs about 1.4 times the tonnage. Aluminium 5052 sits near half. If you're quoting stainless on a machine size for mild steel, check the number first. Bend length is the distance along the die, not into it. A 2-meter wide panel needs tonnage for 2 meters, no matter how short the flange is. People think a shallow flange takes less force. It doesn't. The punch contact's the same width either way. The formula won't tell you about off-center loading. Bend a small part to one side of a long bed, and the load splits unevenly between the cylinders. Do it enough and you wreck ram parallelism. Some machines have tonnage per meter limits specifically to prevent this. The most expensive mistake is buying the wrong capacity. A shop bending 3 mil meld steel all day doesn't need 200 tons. The formula says about 25 per meter. Run the calculation on your actual job mix before you sign the order. One more thing the chart won't show. Under load, the ram and bed bow in the middle. On bends over 2 meters, that means the angle in the center differs from the edges. That's why serious machines have crowning, hydraulic wedges in the bed that push back and keep the bend consistent end to end. So the number isn't just tonnage, it's thickness squared, die opening, material strength, and bend length, all in one equation. Get any wrong and you stall the machine or break a tool. Subscribe for more. Next up, air bending versus bottoming versus coining. The 3 bends.